So that's why we're going to build rockets. We're not only going to measure the altitude, we're going to have a contest too. The highest altitude, then we're going to have...
Are we going to have partners?
No, everybody's going to work on them by themselves. Except, everybody gets to launch their own rocket, but we're going to need help finding these angles. Since you're going to be launching your rocket over here, your friends are going to be over here measuring your angles for you. And so everybody's going to get to launch the rocket. Most people are going to have jobs. Everybody's going to have a job to do. Some people are going to measure these angles. Some people are going to measure how high the rocket goes. And other people are going to measure how long the rocket's in the air. We're going to have all this data. And then you get to figure out things like who's went the highest, who's went the furthest, who's stayed in the air the longest, who had the fastest speed. How do you figure out speed from... A speedometer? No, we only got time and altitude.
One of those.
No, we don't have a radar gun. Allison.
What about with the stopwatch?
A stopwatch gives us speed, but not stopwatch gives us time, not speed. What is speed?
How fast?
How fast, and what's it measured in?
Miles per hour.
Miles per hour. Miles per hour. So it's equal to distance divided by time. And what's our distance? Our altitude. And we'll have time. So distance divided by time gives us speed. And so that's how we're going to find out whose rocket went fastest and who's went the slowest. Any other questions? You have a question? No.
No, wait, it's important. For the contests, there are going to be prizes if you win.
Yeah, well, I'll have prizes for you.
But what if you lose?
What if you lose? There's no prize for losing.
What about candy?
One of the other things that we're going to do to see how accurate our altitude is. This right here is called an altimeter, and this by itself will measure altitude. Does anybody know how it works?
Nope.
Allison knows, but don't tell us, Allison. Okay, remember the Earth. Can you all breathe air on the Earth?
Yeah.
Okay, if you're in space, is there air in space?
No.
Why not?
Because there's no atmosphere.
There's no atmosphere. Good, good. He's doing good.
That's amazing.
Okay, on the surface of the Earth we have atmosphere. This is this dark line, that's our atmosphere. When you get into space, there's no atmosphere. So between the Earth and the space, the atmosphere gets thinner and thinner and thinner until when you get into space, there's no air. And what this little device does is it measures how many molecules of air it senses. So when it's close to the Earth, it measures a lot of them. The higher up you go, the fewer there are. So how it works, there's a little button on it. You press the little button, you hold it until it gets 4 zeros. So right now it's 4 zeros. So now how can I simulate no air? I heard it, somebody said it. What was that? Say it loud.
Sucking.
Sucking. Okay, so I'm going to put it in my hand and I'm just going to suck the air out. So right now, tell me what number's on there.
0.
0. Can you verify that?
0.
0.
Just because.
How much air do you think, how high do you think I sucked out?
3 million.
You want to make a guess?
2. 300. 4. 300. 343. Oh, it was so close.
Nope.
What is it? 45.
3,143.
Yeah. So
You make it go 200 feet.
I was able to suck to a point where there's so little air. It was about 3,000 feet up.
Can I suck?
You want to try it? All right. So it's 3,143 feet. If you can, I'm taping myself. Go ahead.
Oh, I sucked one.
1,655. I got better lungs than you. Anybody? Oh, one more person. One more person.
Not kidding.
Where'd it go?
You have one?
Okay, first make sure it says 0.
It doesn't say here.
Okay, no, push the red button till it, hold it. Allison, please sit down. She can do it.
Okay, it says 40. Okay.
Okay,
Now it says 0.
okay, put it in your hands and suck the air out. Okay,
It doesn't say anything.
it still says 0? You're kidding. Try it again, try it one more time.
No. That's the last person.
Okay,
Suck quick.
It still doesn't.
let me see if you, make sure you didn't break it. No, you didn't break it.
It's really bad.
But I've been doing good. This, like this. Ready?
Ready?
Don't do it too, don't suck.
It says 0, right?
Your fingers
Still at 0.
Go like this and suck between your thumbs.
Like what? Like this?
Yeah, you make sure that everything else is real tight. Still 0? One lesson. It was at 0.
Try it once.
Oh, was it? No, this is the last one, and we got to move on. We got Bill Rockets.
Are we gonna have one though?
I'm going to have them. I'm going to let you borrow them.
How much are they?
They are more than you can afford.
How much is more I just got a check. Come on, lay it on me. Well, not like this. Lay it on me too.
My allowance is $5 a week.
Hold it.
Pay you back.
Put your hands together like this.
Hey, you're really close.
I think you
Yep.
don't have to hold it.
Can I do it?
That's good. We should get a number now.
What one? 100.
100?
Try. Can I try?
She's exactly 100 feet. That's pretty good. Okay, that's it. That's it. Okay, now we're gonna. So what are we gonna do with our rockets when we launch them? What are we gonna measure? What are we gonna measure? Altitude and what else? Speed
Are you gonna attach?
and angles for where it lands. And one other thing. Time.
I have one question. Are you gonna hook that onto one of the rockets we're gonna make?
Yeah, basically what we're going to do, in your rocket, you see this big rocket here, see the big hole in it?
Yeah.
Well, remember the air, it has to sense air, so we need a little air hole in there. So that's what this little air hole is. And what we're going to do, and you'll see this, we're going to attach this little hook to the bottom of the nose cone. So when it's in the rocket, it just senses the air inside the rocket.
And then will it stop when it?
It stops when it reads the lowest pressure. That's when it stops.
What is the lowest pressure?
Well, if you get it all the way into space, it'll be 0. But this can only read up to 29,000 feet. But we're not going that high.
29,000 feet.
What if it did?
Okay, now everybody gets a rocket.